Welcome, students. In this session, let us look at the architectures of artificial neural networks. So, as we already know that artificial neural networks combination connection of several neurons, detailed structure and the functions we have already learned. So now let us go for how to combine these neurons so that we can have the overall architecture. So it is classified based on the architecture and also based on the training algorithm. First, let us have some idea on the architecture. So based on the architecture, all the neural networks are classified as single layer ANN and multi-layer ANN. So multi-layer ANN is the place where we have our deep neural network concepts also. So one of the significant difference between artificial neural network and biological neural network is that neurons are available in a random fashion. But in our architecture, we are going to have everything in an orderly fashion. The reason is we are not able to mimic the exact biological neural network in an artificial way. So this is the architecture for single layer neural network. You can see the diagram. You have layers, column-wise arrangement of neurons, and you have a links and which are interlinked with the weight values. Now let us see the explanation of single layer ANN. Each circle in the architecture represents a node or a neuron. Because they are arranged one below the other, we call it as a layer or a column-wise arrangement of neurons. Always the single layer neural network will have one input layer and one output layer. So why it is called then as a single layer? Because 1 plus 1 is 2. You have two layers. Because the first layer is not counted as a layer. Why we are not counting it as a layer? Because there is no operations of summation and activation function, which are the general operations of a neuron, is not happening inside the neurons in this layer. It is used only for the distribution of inputs to the subsequent layers. So if you feel that it is more confusing for me, then you can also leave the circle for the inputs. How many neurons should I have? Each layer can have as many neurons as you like. It depends upon the application you have. Normally, if you have a classification application and if you say that these are the features I am using for classifying my data, then your input layer neuron is equal to the number of input feature of your application. In the same way, the number of classes is a predefined value which is assigned to the number of neurons in the output layer. Each output layer neuron will give you a single output. So combined together, we are going to take a decision. All the neurons in a layer will be connected with all the neurons in the subsequent layer. This is the important condition in ANN. If you have 10 neurons in the first layer and 20 neurons in the second layer, you will have 20 cross 10 interconnections, 200 interconnections. Each link or a connection between one input neuron and output neuron is always represented by a weight value. We have already seen what is meant by a weight value. So this is the process of the weight value where it can be represented in the form of a matrix. The first value in your suffix shows the row or a source, and the second value denotes the destination. Likewise, you will have an n cross n architectural weight matrix. Advantage. What is the advantage of single layer neural network? It is simple in terms of architecture. However, because of the less number of neurons, you may face less accuracy. Now let us come to the multi-layer ANN. Here you are seeing two diagrams. The one on my left hand side is having one hidden layer, but on the other side you have two hidden layers. So whenever you go for multi-layer ANN, you can have as many layers as you like between your input layer and your output. So these are called as hidden layers because they are hidden from the output or the error value, which we will study later in our training algorithm. Sometimes you can also call it as a middle layer since it is hidden from the error value, which is estimated after the output layer. Apart from the number of neurons you have in your layers, you can also have as many hidden layers as you like. In our deep neural networks, the number of hidden layers are extremely high. Input layer is not counted as a layer, and also the connection is between the subsequent layers in the artificial neural network. Depending upon the number of hidden layers, the complexity also will increase. The weight matrix increases. When the weight matrix increases, the number of weights you need to adjust also will increase, which will ultimately result in the complexity of your overall architecture. What are the advantages? The main advantage is the better accuracy. So how do you say your single layer ANN is with less accuracy and your multi-layer ANN is with higher accuracy? This is because of the number of neurons. That may be one of the reasons. Due to the increase in the number of neurons, the decision taking possibility has also increased. But always keep in mind, just by adding neurons, you are not going to get a better result. More complexity. This is one of the drawbacks due to the increased set of weight matrix. When the number of weights increases,